question says, find the equivalent resistance of this circuit and the current passing through this one here, the R4 resistor. That's the question. First things first, just for the notes, an equivalent resistance is a singular resistance that will have the same value as two or more resistors or two or more resistances arranged in either parallel or series. That's a past question too. Alright, so we have to find equivalent resistance here. What we need capacitor? We said what you use here is called circuit reduction technique. Take them either in twos or in threes. And I said when it comes to a circuit diagram, where do you start from? You start from what? The closed end to what there? The open end. In this case, there is no readily closed end. There is no readily open end. If I look at the question already, they've given you an expo. They give you expo as R1 and R2. Now, assuming R1, R2, R3, R4, R5, and R6 was not given, where do you start from? From here. Start from here. My first step now be, if I look at R1 and R2, are they in series or parallel? Parallel. Alright. So solution please. We have that R1 and R2 are in parallel. Alright, so let's get the equivalent. So the equivalent of R1 and R2. Now observe, if I get equivalent of R1 and R2, it will not be the total equivalent. Because I think you have to resolve this other ones here. Alright, so that means it becomes what there? R7. My last resistance is R6. We'll call the equivalent of 1 and 2 as R7. So since they're in parallel, we say your what? Formula is what? 1 over R7. Where R7 is the equivalent of 1 and 2 in parallel, will be equal to 1 over R1 plus 1 over R2. So I have that 1 over R7 is equal to 1 over R1 is 6 ohm plus R2 is 3 ohms. So I have 1 over R7 is equal to LCM here is 6. 6 over 1 is 6. 6 over 6 is 1 times 1, 1 plus 6 over 3 is 2 times 1, 2. So this is equal to 1 plus 2, 3 all over 6. So get this one here in fact. That means R7 all over 1, which is equal to R7 is equal to invert this 6 all over 3. That makes what there? 2 ohms. From here now, you now draw the reduction diagram for this. And we said for reduction diagram, this one here, move this. How do I do this here? That is on that will contain. I doubt. So let me draw it here instead. From here, I have just resolved only these two here. So that means this part here has the same thing. So redraw this. I have this one, this one, this comes down, goes this way. Okay, goes this way. This way here. Alright, so look up. The same circuit here is 28 volts. Repeat it here. 28 volts. Here is R6, 2 volts, 2 ohms. So 2 ohm resistor. Here is R6. R3. Here is 4 ohm. R4. Here is 12 ohms. R5 equal to 8 ohms. So look at this. Observe that I resolve R1 and R2 in series. So these two now resolve, give you this one here, which is now R7 being equal to what there? 2 ohms. So I have this R7 being equal to 2 ohms. So I'm here. What next? We'll still continue the reduction of this circuit. So at this point now, which two or which three can I pick next? That's the question. Which are which? This and this next, please. This one and this thing. Alright? You can see that this one here is dividing this into this half and this half. To start with this half here, becomes this two. R7 and R3, are they arranged in series or parallel? Series. Observe is end to end. So it becomes series. So hence, I have R7 and R3 in series. Let's resolve. So next one, we said R7 and R3 in series. Alright, so we said in series, the equivalent is simply add them up. If I want to get equivalent of R7 and R3, it will not be my final because I still have to work with this one here. So because of now, R8. So I'll have that R8, the equivalent of R7 and R3 is equal to, for series connection, we say add up the resistance straight up. So it becomes R3 plus R7. That's equal to R3 is 4 plus R7 is 2. That gives you 6 ohms. So it becomes 6 ohms. Draw your next circuit diagram. So here's our first movement. Draw the next one. The next circuit diagram comes here. So I'll resolve these two. It will now come this way. Resolve these two. It will now come this way. So I have this. I have Alright, so look at this. Alright, so look at this. Look up. We've got R8. We said R8 there is equal to 6 ohms. So I have 6 ohms here. What's the next step here? Next step is what? R8 and which of them? R4. And R4, please. Next one is R8 and R4 what there? Parallel. So we have R8 or R4 and R8 in parallel. So the equivalent of R4 and R8 is not my total resistance. It's not my equivalent resistance yet. So I'll have an R9. So in parallel, so take inverse. So it becomes 1 over R9 is equal to 1 over R4 plus 1 over R8. 1 over R9 is equal to 1 over R4 is what? 12. plus 1 over R8 is 6. So I have it. What is up here? This is equal to square root of 6 and 12. Is 12. 12 over 12, 1 times 1. 1 plus 12 divided by 6, 2 times 1, 2. So I have 1 over R9 is equal to 2 plus 1 plus 3 is 3 over 12. And that will give you, to get this value here, invert, it gives you R9 over 1, which is R9 is equal to, invert this, it gives you 12 all over 3. So that means R9 is equal to what there? 4 ohms. Alright. Next step, bring this down again. Bring this down. So this 2 gives you 9 ohms. So redraw your diagram again. I'm having this. Alright, so here's my 28 volts. Here's R5, still untouched. We said R5 is equal to 8 ohms. Here's R6. R6, whose value is 2 ohms. Finally, we resolve these two in parallel and we got the answer as 4. So this is R9, whose value is 4 ohms. Alright, so I've reviewed these circuits from these two first. I had this one here. These two next in series. I had this one here. These two here in parallel are now here. Next one, if I look at this, you can see that the end of this is connected to the end of this. The end of this is connected to what there? This end. So it becomes an end-to-end connection. This is what there? Series connection. Alright. So finally, I have that R5, R6, and R9 are connected in series. Alright, so let's get this. So R5, R6, and R9 in series. So we said for series connection, the idea there is just simply add them up. Now, here's the observation. If I add up 1, 2, 3, I'm done with the resistor. So because what there? REQ. That's it. So no longer RE10, but REQ. Because if I add up 1, 2, 3, I'm done. So it becomes my total or my equivalent resistor. So REQ then, equivalent, is equal to R5 plus R6 plus R9. That's equal to R5 is 8 plus R6 is 2 plus R9 is 4. So R equivalent is equal to what there? 14 ohms. Alright. So we are asked to find the equivalent resistor. We've done that. Our answer is 14 ohms. Finally, draw your last circuit diagram. What will it be? Voltage first. To 8 volts, so 28 volts. Yes. So here's REQ being equal to 14 volts. So I have this. Alright, so we've gotten the equivalent resistance. So we have this. Next, I said find the current, I mean, in the R4 circuit. So let's get that one done. So next, I've said find the current in the R4. This one here, the R4. All right, the fourth resistor for R4 here. Find the current in this one here. What do you do here? We said note two things. that when resistors are arranged in series, when resistors are arranged in series, what happens then now? Same what? Same current flows through them. Please take a place. When resistors are arranged in series, the same current flows through them. Number two, when resistors are arranged in parallel, what was that? The same potential difference or voltage flows through them. Please note this thing, please. We'll use this condition in analyzing this. So listen. Find the current in the R4. How do you start? Listen up, please. So of course, I'll start from here. I'll move backward until I get back to this. This is the backward process. Now, how do you start? Start with this one first. Start with this first. For this one, let's get our current here. What's the current here? From Ohm's law, we said V is equal to IR, such that I is equal to V over R. That means the current in this circuit, I, is equal to V all over my equivalent resistance. So this over this. So it becomes equal to, this gives you 28 all over what there? 14. How many there? 2 ampere. So the current flowing in this one there is 2 ampere. Now look at this. I'm now doing a backward tracing. I got look at this. I got REQ. Please listen so you don't miss it. I got REQ by combining R6 or by combining R5, R6 and R9 in what there? In series. If I combine them in series, what will they now? The same current. That means the current, so it means that the current flowing through the equivalent resistor is equal to the same current flowing through the R5 circuit is also equal to the current flowing through the IC circuit is also equal to the current flowing through what there? So I have this. That's the condition there. If this is true, I have that this. That means that this whole value, of course, we've gotten this one here as 2 amperes. That's this one here. So that means that I5 is equal to 2 amperes. I6 is equal to 2 amperes. And I9 is equal to 2 amperes. That's your first task there. Keep that one pending. We are now at this one. We're done with this. We are now here. So what next? I'm looking for R4. Now, if you observe, R4 here, which is what we are asked to find, you have to find this. This one here was untouched to this point, the same thing here. This one here was untouched to this point, same thing here. So if I'm moving from here to here, what do I note? I notice that if you can check your work, notice that we got R9 by combining what there? R4 and what? R8 what there? In parallel. So I got R9 by combining R4 and R8 in parallel. If I combine them in parallel, what is there? That means the voltage across R9, that's V9, is equal to what there? V4 is equal to what there? V8. So first task, let's get the value of V9 first. And let's get V9 first. That's the task. Get V9 first. So since I got R9 by connecting R4 and R8 in parallel, the voltages between them is the same. So it means that V9 is equal to V4 is equal to V8. Let's get the value of V9. From Ohm's law, V is equal to IR. That means that V9 is equal to I9 times R9. Help me out. What's I9 mean? 2. What's R9? 4. So that gives you what there? 8 volts. So please notice that V9 is 8 volts. If V9 is 8 volts, what does it mean? It means that V4 is also equal to what there? 8 volts. And V8 is equal to 8 volts. So they are both 8 volts because it's in parallel. One last thing. If I have V8, I have R8. Sorry. If I have V4, I have R4, I can now find I4, which is the current passing through the R4 resistance. Yeah? I can do that. Alright, so how do we do that? Next up, I want to click it. So we said V4 is equal to 8 volts. We have to find the current here. So recall that from Ohm's law, V is equal to IR. So it means that voltage across R4 is equal to I4 times R4. We have to find I4, the current across the R4 resistor. That means from here, I4 is equal to divide both sides by R4 becomes V4 over R4, of course. Make I4 stand alone. You have this. Or according to the formula, you have this. That's equal to what's V4? 8 all over what's R4? 12. That means I4 is equal to 8 over 12. In this one we have 0.66 units amperes. So therefore, the current flowing through R4 is equal to 0.67. That's 67, I mean. 667, right? 0.67. That gives you 0.67 amperes. So this is how you find this one here. That's how you do this. Let's read it back up.